So the Quine-McCluskey method. Now, we want to simplify this expression. We'll do it both ways. We'll see if we get the right answer at the end. Now, I have these expressions. So this is W. Let me actually use the graph paper. It will be nicer. I'm going to label this W, X, Y, and Z. Well, before I do that, so let's look at it. W, X, Y, and Z. I'll look at it right here first. Let's look at the 0. The code for the 0 will be what? 0, 0, 0, 0, right? That's the address for 0. What's the address for 4? 4. That'll be what? 0, 1, 0, 0. Isn't that what 4 is? What about the 5? 0, 1, 0, 1. What about the 7? 0, 1, 1, 1. What about the 8? 8 is what? 1, 0, 0, 0. What do we have after 8? 11. What's 11? 8 and what? 8 and 3 is 11. 12 is what? 8 and 4. And the last one's the 15, which is 1, 1, 1, 1. So the way that Quine-McCluskey method works, there we go. I'm going to put my graph paper here, right next to it. I'm going to just put a line here to separate them. I'm going to break them into groups based on what? It's based on how many zeros in that group. So we begin with the 0. The 0 has how many zeros? 4. That's the only one with 4 zeros. Now the next group is the group with only 1 in them. 1, 1. 1, 1. Where do you see 1, 1? I see the 4, which is what? 0, 1, 0, 0. What else? I see the 8, which is what? 1, 0, 0, 0. Anything with only 1, 1 in it left? No, right? So that's my second group. Don't run the line too long. Be cheap on the paper because you're going to see it's going to add up more columns. Now, how about 2 ones? I see the 5, which has what? 0, 1, 0, 1. That's the 5. That's 2 ones. I see the 12, which is what?
1, 1, 0, 0.
1, 1, 0, 0. Now the 3 ones in them. I see a 7 has 3 ones in it. That covers the 7. The 11. And finally I see what?
15 has 4 ones.
The 15 has 4 ones. So we cover them all. And that's the only sheet I need for the rest of the day. Now, next column. I said be cheap with the paper. So I'm going to put a line here. Break them down to groups here too. Let me just erase that extra lines I put there because I wasn't listening to myself. Now I look at these two. I'm going to break them now 0, 4. 0 and 4. I'm going to look at this and look at this. Notice the 0 stayed the same. The second location changed from 0 to 1. That means it's not important. We'll put a dash there. And the other ones are zeros. And you want to put a check mark next to it. You'll see why we put a check mark. Now what about 0 and 8? That'll be what? Check mark 0, 0, 0. Extend the line now. And put a line here because we're going to need it later. So there's a check mark next to the 8. I already have one next to this. So I try the adjacent one. I look at this with these guys. See if I can break them down. Now let's look at this and this. Can I check the 4 and the 5? They have to be different only by one cell. Let's look at the 4 and the 5. Are they different by one cell? Yes. Put a check mark next to the 5. Let's write here 4 comma 5. So 4 comma 5 is going to be what? 0, 1, 0 dash, right? 0, 1, 0 dash. Notice I tried to line up with this. How about 4 and 12? Can we do with 4 and 12? Yep. 4 and 12. What do we have? Dash 1, 0, 0. I'm not done. How about the 8 and 5? 8 and 5. Notice they're different by how many locations? 2. Can't do it, right? How about 8 and 12? Only different by 1, which is what? Second one? So 8 and 12, that's 8 here, and 12. It's dash, oh, sorry, 8 and 12 is 1 dash 0, 0, right?
So it doesn't matter if they're plus one. It's only by one.
By only one location.
Anywhere.
Yep. 1 dash 0, 0. And I'm done. There's a check mark next to every one of them. That, when you have a check mark, when you go to the next one, that means, okay, good.
Is it 1 dash 0, 0 or 1?
1 dash
Those backwards.
8.
0, you did 1 0 dash dash.
Oh, 8 and 12, 1 dash 0, 0. I said it right. I wrote it wrong. Okay. Next. So we did all these. Let's look at this group with that group. How about the 5 and 7?
We differ by 1.
Yep, different by 1. Good. So here's a check mark next to 7. 5 and 7, that'll be what? 0, 1. Is it dash 1? That gives me a check mark next to the 7. How about 5 and 11? The first location is different, the second location is different, the third one is different, so I can't do them. How about 12 and 7? Nope. How about 12 and 11?
No.
Nope. That's it. That group is done. It's only one of them. Boo-hoo. We like a lot of these. So now what about this and this?
7 and 15.
7 and 15. That puts a check here next to this. And that'll be what? Dash 1, 1, 1. How about 11 and 15?
Yeah, by 1.
Puts a dash next to this. And that's 1 dash 1, 1. Notice the fact I have checks next to each one of them. That means in the future, I never have to look back at this column. I could just cut it out of my picture. It will not change my answer. I don't have to look back. If I don't have a check next to it, you'll see what's going to happen with the next group. They're not going to deal with it. So now we're going to repeat the process with these. We're going to repeat the process. Let's look at this and this. They can only be different by 1. And the dashes have to match. So when I look at the 0, 4, is that a 12 here? The only one that could match is what? The 8 and 12. See the dash in the second location. So when I look at that, I could do 0, 4, 8, and 12. That's this one and this one. And that will give me what? Dash, dash, 0, 0.
So you're only looking at the dashes.
The dashes have to match.
Just the dashes.
Yep.
Nothing else.
Well, then the rest have to be different by 1. The dashes have to match, and the rest of it has to be different by 1 digit. Now let's look at 0, 8, and 4 and 12. Can we connect them?
Yeah.
0, 8, 4, and 12. If you did that, that would be what? Dash, dash, 0, 0. Don't write it down. Why? 0, 8, 4, and 12. The same set of group, right? It's the same answer. So, but there's a check mark now next to this one. That's all it does. I need that check mark. I'm done with that group. Now let's go to this group here.
4, 5, 6.
Nothing. The dashes doesn't match anywhere. That's why it's the graph paper. Look at what my dash for this one. See this? My dash here, there's no dashes here. So between this and this, not going to be any match. So I don't even have to look at these. Let's look at these. I don't even have to look. Why? Look where my dash here. There's no match. But now I don't have a check mark here. I don't have a check mark here. I don't have a check mark here on that one. The ones with the check mark, I'm done with them. So those are the ones without a check mark. We got this table. Perfect. Now, how are we going to read it? Let's go right here. And now let's read that. I said be cheap with the paper. I wasn't. There we go. When we started the problem, here we go. When we started the problem, let me leave a space here. I'll come back and put some stuff in it. I was using what? W, X, Y, and Z. So I'll leave a space. W, X, Y, and Z. That's good here. I can put a line here. Let me go back to the original problem. What was the original problem? Where'd you go? The values are what? 0. There's the 0. Let's put a 0 here. 4. Let's put a 4 here. 5. Let's put a 5. 7. 8. 11. Bless you. 12. And 15. That's my expression, right? 0, 4, 5, 7, 8, 11, 12, 15. Now, let's begin with this expression. I marked it in green. If you were writing the value for this, That's, remember, W, X, Y, and Z. That bar, the dashes, it doesn't matter what W is. It's not going to be in the answer. As long as Y is 0 and Z is 0. So the way you will write that, that'll be what? Y bar, Z bar. The expression for that, Y bar, Z bar, right? And that will cover which one? 0, 4, 8, and 12. Let's go to 0, put an X there. Let's go to 4, put an X there. Let's go to 8, put an X there. And let's go to 12, put an X there. This term covers all 4 of them. That's what it says here, 0, 4, 8, and 12. Let's look at this one here, 0, 1, 0. See that? If you were to write that, that's what?
W, X, not Y.
I'm using W, X, Y, and Z, right? W, X, Y, and Z. So that'll be what? W bar. The second one's what? X, and that's Y bar. W bar, X, Y bar. This one covers which one? 4 and 5. Let's put an X at 4, put an X at 5. The next 3 is still highlighted. These 3 here. This one is what? This is, oh, I'm looking at this one, I'm sorry. This one.
It would be
W bar. X, Y is gone, Z. And that will cover what? 5 and 7? 5 and 7. Two more. Next one, this one. W is gone, X, Y, and Z. And that covers what? 7 and 15. Where is 7? Got to make sure we stay in the same spot. And 15. Am I in the right column? Yep, 15. And the last one, 11 and 15, that's which one? W, Y, and Z. That's 11, 11, and 15. This is what we did, just like the book, X's. Now watch what's going to happen here. Let's see if they have a good picture here. In color, I was looking, nope, they don't have, I get my colors here. Now, oh, where'd you go? Oh, I knew something was missing. Our job is to pick all these X's out. I need different colors. I get, come on, I get yellow. I get pink there, the blue. I don't know where the blue is. I get the green. This one I have to choose. You'll see in a minute why. Because there's no way to get rid of, to pick this without choosing this row. If I pick this term, this one, see this one? Is going to pick all these X values. The way this one works, it also picks anyone along the way. So this one is gone now. You can read them up as, is there anything X's in that column? Just in that column. If there's anything along the way you can pick. Is there anything down here? No. Is there anything down here? No. So that gives me that term there. That covers all of these. That's Y bar, Z bar. I also need to pick this one because there's no way I can pick the 11. There's nowhere. I can pick the 11 from anywhere. It's like a prime. When you pick the 11, this one is gone now. I already took the 15 out of this one. Plus, that will be what? W, Y, Z. And now be smart. Which one are you going to pick? The middle one. Why the middle one? Because if I pick that middle one here, that picks this one along the way, and it picks this one along the way. So if I simplify that, that should give me what? W bar, X, and Z. Let's see if that's the answer. Do the K-map. I'm going to do the K-map, see if I actually do it right. So here's my K-map. To see if that method really works. Curious about it. W, X, Y, and Z. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now we have a 1 at 0, at 4, at 5, at 7, at 8, at 11, at 12, at 15. Anything else? Now notice if I group these four, I can go this way. Let's show up on the screen the yellow color. I can do a greenish color if that doesn't show up. If I take these four ones, can you see it on the screen? Yep. And I take these ones here and these ones here. Does that cover them all? So if I take these ones, what do we have? Y bar, Z bar. If I group these ones here, what do we have? W bar X and what? Z. And if I take these two, what do we have?
W, Y, Z.
W, Y, Z. Is that the same answer?
Yes.
It's amazing.
How fast?
Somebody figured that out. That's a question for... Well, I know you're going to ask me that one. Somebody did. And figure that out. That's the amazing part. We just take for granted. We just do them. So, oh, Quinn did that. Quine-McCluskey. What made him do it? How did he figure that out? I'm sure you can Google that and see. And whatever story they told, because that's not new stuff. It's an old stuff. It's passed on by generation. Probably not a true story. You know.
It reminds me of E equals MC squared. I would always wonder what Albert Einstein was thinking on his way to
Yep.
making that equation.
We can't prove that's wrong or right. E equals MC squared. It says you have so much energy in anything. If this one's sitting here, the amount of energy is the mass times the speed of light squared. If we can take that energy out, we can light the whole city of Springfield from this cup of coffee. But nobody figured that out. So who knows if he's telling us the truth or not? I don't know.
Make thorium reactors instead of uranium reactors.
But that's how the Quine-McCluskey method. It's not really a difficult one, but you can see you got to be 100% focused when you do that. Unless you're really talented with computers and you can put them in an array, two-dimensional array, and look for matching ones to see if this the same and this the same. And we used to actually do that, make them write a program for it. Every semester we attempted that. We never got one person to do it right. Maybe once. I think maybe we had one or two in about 10 years. Somebody actually got that one right. Get the program to work. But I mean, keep in mind, these are first-year programming students versus someone who really does that all day long. So if you're a programmer that you do that all day long, that's not a difficult program to write. But for first-year students programming, that's a challenging program to write. Yes?
What would be the preferred language to write a program for that?
Oh, you can use any language. Whatever you feel more comfortable with. I mean, if you like not mathematics. If you like Java, if you feel more comfortable with Java, do it. If you do C++, that's fine. Just looking to see if that matches this. You know, does it equal to hyphen? Does it equal to 1? Does this cell equal to that cell? All you ask on the computer. If that's the case, then no change. But if there is a change, if there is difference, so when you ask them, you go, is this cell 5? For example, if I was writing a program, let me stop the camera because I'm just talking about programming now.